Welcome to the Talking Lab Guide for Tivoli Storage Manager 6.2. In this guide, we will highlight the deduplication functionality within Tivoli Storage Manager and TSM Fastback. In addition, we will illustrate Flash Copy Manager functionality and how deduplication can be applied to snapshot-based backups. To begin, we have a TSM server running version 6.2 and a logical T drive, which represents a traditional user share environment. We have a couple of user folders, Bob and Sue, along with a public folder containing common data. We also have an excluded folder and a database export that we will use later in the lab. Our first backup of the T drive, using client-side deduplication, reported around a 52% reduction ratio. We can also see, based on the summary information, how much data was inspected and subsequently backed up over the network, and that highlights a large advantage of client-side dedupe, which is reducing our network utilization by eliminating unnecessary data transfer of duplicate data. Combined with TSM's progressive incremental approach, backup traffic is kept to an absolute minimum. In this lab environment, we have three storage pools. We have a dedupe-client, which contains client-side deduplicated data. We have a dedupe-server for server deduplicated data, and a dedupe-fcm for Flash Copy Manager data. This too is server-based dedupe. In a typical configuration, you would not separate out these different data types, but we have done so in order to individually illustrate each dedupe method and its results. Looking at the TSM server, we can run a predefined script against the occupancy table and view the reported dedupe levels. Since TSM deduplication is based by storage pool, it offers considerable flexibility for developing your dedupe strategies. Allowing for data segregation based on file type or entirely excluding certain data types will not dedupe effectively. If we look at the output, we'll see on our dedupe client storage pool, our logical megabytes closely matches our number of bytes processed and sent over the network from our client backup. Dedupe-server, which contains data from the same logical T drive, shows a one-to-one relationship and actually more data because we have excludes on the client backup. TSM server-based deduplication is post-process, and to actually identify the duplicate data, we need to run what's called an identify duplicates process. So we're going to kick that off now. This identified duplicates process is volume-based, and it runs obviously by storage pool. So it's going to scan through each of the volumes that it hasn't processed yet or contains new data from its last run. This is represented by the state, which is active. When it finally runs out of activity to do and it processes all the data, that will turn to idle, and the duplicate bytes file will be reported up below. Now, this does not actually save any data for us. This only shows us how much data is to be reclaimed if we run reclamation to save that data. So now we're going to click off reclamation to actually get our savings back. We're going to run this threshold at a value of 5, which is fairly aggressive, but the lower we can drive that value, the more data we can get back from our space savings. There comes a point of diminishing return, though, where you can't process any more data, or it becomes wasteful to spend cycles processing a large amount of physical data to get back a little bit of data reported saved by dedupe. So if we run our report again, we'll see that dedupe server is already getting its data back as reclamation runs. So we're going to let that job run, and we're going to go back to the client side and talk about configuration options. We're going to represent a new user coming online. So we're going to rename the excluded folder to Rick, and we're going to rerun our backup. Now what we're going to get here is a backup that runs with a very high level of deduplication because of Rick's duplicate data, and it'll run in a very quick manner. It's actually querying the server at this point, and it builds a localized database, a hash database, that it uses to compare for duplicate data. When it finds duplicate data, it does not send it to the TSM server, thus saving us our time and network transfer. So at this point, we had a very high ratio, well over 95%, and our processing time was only 12 seconds out of 233 megabytes inspected. It's important to note, when we're looking at client-side dedupe, while this particular model was very successful, clients can be very sensitive to the extra burden that can be placed on processing certain file types. Large files or data that's going to be not deduped effectively, we want to avoid processing that data. So within TSM, we can actually do a exclude.dedupe. So we're going to do that on our exported file at this point. Now, while this excludes it from the client-side deduplication, if the data is still stored or backed up to a storage pool on the server that is set up for deduplication, it can still be deduplicated. If we really wanted to isolate this data and not include it in any deduplication, client or server, we'd want to create an extra management class and a storage pool and bind it to that location. For example, and include start at back to the non-dedupe pool. For this illustration, we're going to just exclude it from dedupe and we're going to back it up in its native form. So we save our file and rerun our backup. Checking back on our TSM server, we'll see reclamation appears to be complete, and if we rerun our dedupe report, our dedupe rate has increased and we've gotten around 42 megabytes of space savings at this point. While this backup of the client runs, we're going to jump over to Flash Copy Manager and do some backups of the Exchange environment. Now, for those of you that don't know, Flash Copy Manager provides application-aware backups using snapshot technologies. Within this environment, we've configured it to use both local storage, local VSS, and TSM storage. We've also already run a full backup, so our second backup will help us with our dedupe rates when we process the data on the TSM server. So as you can notice here, we do have selections for TSM server or local or both. We're going to retain both, and we're going to kick off a backup. Now, while both of these backups run, we're going to pause the demo for a moment because it'll take a few minutes for these to complete. Coming back to the lab, we'll see that the backup for the Exchange environment has completed, as well as our backup of our BAK file, not using deduplication. If we check our TSM server, we can rerun our report, and we'll see that our dedupe client data, which had gone up on the previous backup of the RIC folder, has now been reduced with the BAK environment. Now, we could process this storage pool with an identify duplicates to process the BAK file, but we're not going to do that in this lab at this point. Looking at dedupe FCM, we'll see that we have two full backups actually that represent around 67 megabytes of data. So on this storage pool, we are going to initiate an identify duplicates process. Now again, as this process runs, it's scanning through the data looking for duplicate data, and it will report at the end about our duplicate bytes found. So that would represent the maximum savings we could possibly obtain if we were able to reclaim every little amount of space savings identified. Now that it's idle, we're going to kick off reclamation for that storage pool. Rerun our report, and we'll see dedupe FCM is actually starting to get his savings back. While that runs, we're going to actually go over to our fastback environment and talk about fastback deduplication. Fastback is another product of the TSM suite that offers disk-based backups from a block level perspective, and it can do incremental block level as well. Now, when you apply deduplication to that repository that it uses, that can give you a very effective reduced footprint for your data repository. In addition, with the incremental block level approach, you can also enable very frequent backups, giving you a very high level of recoverability to specific point in times. So in our environment, we have the same T drive we've been backing up. We have under a snapshots monitor, we have a T drive backup that was full, and our dedupe ratio at this point is a little bit less than 2:1. We're going to kick off another full backup of this environment and illustrate how the dedupe ratio increases and how fastback itself is working. So if we kick off a full backup, we go to our snapshots monitor page and we'll see that process in play. And it will try to give us an estimated time of duration that it's got left to complete the backup. In addition, we have a repository status, we have a throughput monitor, and we also have our dedupe ratio that will continue to fluctuate, and then eventually when we get to the end, it'll be at its highest level. While this backup runs, we're going to pause the lab again and let this process complete. Returning to the lab, we'll see that our backup is completed and our dedupe ratio is increased to about 3.4:1. So again, because we have two full backups, we're going to get very effective rates. Moving forward, you would traditionally do an incremental from this point forward, which would give you a very low rate of change, a very high dedupe ratio, and maximize that repository space. Going back to our TSM server, we'll see that reclamation is very likely complete, which it is. And if we look at our FCM environment, we will show a 1.6 return rate. Now that's not substantially excellent for an Exchange environment. You will get higher rates with a production environment with more full backups and obviously larger databases that have more duplicate data. So in summary, TSM-based deduplication offers a variety of choices for meeting your data protection requirements. TSM Fastback offers disk-based protection using block-level backups with target-based deduplication, and is included with the product set for no additional charge. Additionally, deduplication can also be leveraged across a WAN or LAN environment when integrated with the TSM server. TSM deduplication offers both client-side and server-based dedupe methods. This can allow for a very flexible, comprehensive dedupe strategy. It too is included with TSM Standard and Extended Edition with your maintenance costs. Recently introduced is the capacity-based pricing model. This allows for entitlement across most of the TSM product set, including all the products you've seen today. This model is based on reported usage of the TSM primary storage pool. So if you're using deduplication, it also uses the deduplicated footprint for the licensing charge. This can really be effective if you're looking to go tapeless to reduce your license costs and maximize the capabilities across the entire TSM product suite. If you have any questions regarding TSM, Fastback, Flash Copy Manager, or capacity-based licensing, please contact your IBM representative for further details. Thank you.